Good afternoon, class. We are looking at section 3.7, derivatives of the logarithmic functions. We've looked at different rules of differentiations, and in this section, we're going to cover the derivative of the log functions after looking at the derivative as a function, basic differentiation formulas, the product and quotient rules, the chain rules. So the synopsis of the section is given here, and we'll cover it with more details shortly. First and foremost, the formulas that you've seen, the basic differentiation formulas, the product and quotient rule, the chain rule, definitions, exponential formulas. We are adding logarithmic formulas right here, and let's get into the details. First and foremost, what we learned in algebra, intermediate algebra, college algebra, and pre-calculus about logs. If we have x equals b to the power of y, it means y equals log x base b. And the base must be positive and it can't be 1. So in essence, we are interchanging the two notations, and there's a methodology to do that. One is a logarithmic notation, one is an exponential notation. I have it here. So what really helps, if we look at this log x base b equals y, and then we pay attention to this arrow and follow that, b to the power of y equals x. If we could do that, practically we are done. So what I'm saying is, log is simply an exponent. That's all there is to it. For example, if we say 7 to what power is 49, it is the same as saying log 49 with base 7. What is that equal to? They both have the same answer, namely 2. And as long as we understand this, it makes understanding logs easy. It is important that we be very comfortable with that, because we want to look at the derivatives of logs, and even there's a part of that in regular calculus course we cover known as logarithmic differentiation. So let's clean up this mess first. And then here's the general properties. Log 1 with any base is 0. Look at the arrow here. If you go with the arrow, b to the power of 0 is 1. Log base b of b is 1. b to the power of 1 is b, which means the first one says log of 1 with any base is 1, and the second one says if the base and the argument are identical, the log is 1. These two refer to the fact that logarithmic functions and exponential functions are inverse functions. And this is easy to see, by the way. B to the power of x is b to the power of x. B to the power of log x base b is x. Exponential and logarithmic functions undo each other. Log xy base b is log xb base b plus log y base b. This is called the product rule. Log of x over y is log of x minus log of y. All of them have the same base b. This is called the quotient rule. Log x to the power of n is n log x. Both of them have base b, same base. This is known as the power rule. Now, if we change the base to a specific one, such as e, then we discuss the concept of a natural log, where the base is e. First and foremost, I want you to pay attention to the graph. of y equals e to the power of x, y equals ln x, and they are symmetric with respect to the line y equals x, and it makes them inverse functions. And by the way, this is important to remember. In the case of a log, the domain is from 0 to infinity. 0 is not included. So we want to be able to go from here, the general case, to a specific case. Notice you change the log to ln. ln1 is 0. Then ln e, because the base is e. If you look at the second one, log b of base b is 1, so ln e is 1. Again, these two are the same as this one. Product rule, quotient rule, power rule. Ln of xy is ln x plus ln y. Ln of x over y is ln x minus ln y. Ln of x to the power of n is n ln x. And we have the common log, in which case the base is 10. And again, you have to be able to make this transition. The base is 10, so log 1 is 0. We don't write the base. When we write log no base, the base is 10. Log 10 is 1 because the base is 10 when we don't write it. Again, 3 and 4, just like this one, the fact that the two functions undo each other. Log 10 to the power of x is x, and 10 to the power of log x is x. Product rule, log of xy is log x plus log y. Quotient rule, log of x over y is log x minus log y. Power rule, log of x to the power of n is n log x. And finally, I want to go over the change of base formula. If you want to evaluate log x base b, it's the same as log x over log b, as long as you choose a common base. Normally, we use common log or natural log. In the case of a common log, the base is 10. In the case of a natural log, it's e. Those are the properties you've seen, you should be comfortable with, and we are going to move on. Now, we want to evaluate those just to refresh your memory. And again, this is log x base b equals y. That means b to the power of y is x. We are going with this arrow that I mentioned. So log 81 base 3, what is that equal to? It's equal to 4 because 3 to the power of 4 is 81. I also remind you what the way it was solved in algebra. Log base 3 of 81. Let's say we don't know the answer, so it's x. We go with the exponential format. 3 to the power of x is 81. We know 81 is 3 to the power of 4. And that's the answer. So this is how we did it in algebra. The second one, log 5 base 25, that is equal to 1/2, because 25 to the power of 1/2, or the square root of 25, is 5. And in this case, we would write log 5 base 25 is missing. Let's say it's y. By definition, 25 to the power of y becomes 5. We know 25 is 5 squared. And so 5 to the power of 2y becomes 5. The exponent for 5 is 1. So 2y must be 1, and y becomes 1/2. This is how we handled it in general. And the last one, log of 0.001, is -3, because 10 to the power of -3 is 0.001. What I want to discuss is powers of 10 while we are here, and that is when the base is 10, remember log 10 is 1. Just look at the number of zeros. Log 100 is 2. Let's say log of 10,000, we have 4 zeros. Now, in the case of a decimals, we go the same way, but we go negative. So in this case, 1, 2, 3 decimals gives us -3. Or you might say, for example, log of 0.1 is -1. Log of 0.01 is negative. This is about common log. Now we want to write this in exponential form. I remind you, of course, with this arrow, log 625 base 5 is 4. That means 5 to the power of 4 is 625. Very straightforward. What would be this one? Anyone? How would we rewrite this?
Seven to the power of 2 equals 49.
Perfect. 7 squared is 49. How about the next one? Get the arrow. How would you rewrite that in an exponential format? Exponential format. One-third to the power of -4 is 81. I don't want you to be scared of negative numbers, fractions, things of that nature. How about this one? How would you rewrite this? Anyone? #81 to the power of 1/4 is 3. The last one, 1/2 to the power of -5 is 32 in all cases. Look at the arrow. That makes it easy to follow. You got to be comfortable with logarithmic properties. You want to study that in case you have a difficult time with that. Y equals ln x, we want to differentiate. We don't know the derivative of that, so we are going to rewrite this in an exponential format, which is e to the power of y equals x. We can differentiate both sides, and we're going to do it implicitly. The derivative of the left side, because it's exponential, it's always itself, e to the power of y. And then y is a function of x times dy dx, or y prime, and x gives us 1. So e to the power of y itself times y prime by the chain rule, x gives you 1. We're going to divide both sides by e to the power of y to get to y prime. And e to the power of y is x, so y prime is 1/x. Which means, in order to get to the derivative of ln x, all you have to do, look at the argument, write its reciprocal. So by the same token, if this is the case, in the case of g of x, instead of x, we have g of x, we are going to write the reciprocal of that by the chain rule times g prime of x. Take a look at this one, by the chain rule times g prime of x. And in many cases, we say we let u be g of x. U is a function of x. So ln u, the reciprocal is 1/u, and the derivative of u is du dx. We are assuming u is larger than 0. In this case, we are just saying x can't be 0, and we use an absolute value. And again, the reason we use an absolute value here, because of the domain I explained, it's from 0 to infinity, or you can go with that format, u must be larger than 0. All right. We are going to differentiate this. I highly recommend you write formulas and follow it. So if I want the derivative of ln of g of x, first I'm going to write the reciprocal. So 1 over 5x minus 1. Then I'm going to tag along g prime. What is the derivative of the g or the argument? 5. And then I'm going to put them together. Now, many times, some students have learned it before, and over here, they're going to write d dx of 5x minus 1, and then they write 5. There is nothing wrong with that. It's just that if you keep on writing d dx of this, d dx of that, it becomes difficult to follow for your own good. And it becomes messy, and it becomes way too long. We want to differentiate this, and I'm going to do it both ways. First, I'm going to just do it the way this one is. So the argument is x cubed. Flip it over. So y prime is 1 over x cubed. And then the derivative of that, according to the chain rule, times 3x squared. And this is obviously 3 over x. And you're done. Now, there is a second method, and that is to use your logarithmic properties to decompose that before you move on. And for this example, it may not make much of a difference, but it does when it gets more complicated. So you look at the original given, and you use the power rule, you put the 3 in front. And so now y prime is 3 times. What is the derivative of ln x? 1 over x. So 3 times 1 over x. It's exactly the same answer. Now, again, it doesn't make much of a difference here, but it does when it gets more complicated. For this example, if we wanted to just get started, we would have to write the reciprocal of this statement, 1 over this, that means 2x plus 1 at top, 2x at the bottom, times g prime of x. Times g prime of x, I have to use the quotient rule on this. Okay. Can it be done? Yes. But most of the time, students who take that route make a mistake because it's a long way. Instead, we are going to decompose this algebraically using logarithmic properties, then do the math. Can anybody tell me how you would decompose this? Anyone? This is what? ln of what? Ln of the top minus ln of the bottom. Make sure you put it in a parentheses. This is called the quotient rule. And ln 2x is ln of 2 plus ln of x. Now that it's decomposed, see how fast and easy you can get to the answer. We want to find f prime of x. Please understand this is a number. So the derivative is 0. This is a number, the derivative is 0. What about ln x? 1 over x. Minus ln of 2x plus 1. Flip this over. 1 over 2x plus 1 minus 1 over 2x plus 1. And then I need the derivative by the chain rule. What is the derivative of the parentheses? 2. I'm done with calculus. Now I take a common denominator of x times 2x plus 1. And then 1 times 2x plus 1 minus 2 times x. So 1 times 2x plus 1. This is negative 2 times x, and the denominator is the product of the two. Two x plus 1 minus 2x, and we are done. We want to differentiate this, and this part, we can write it as 2 ln x. Let's do that, which gives us 5 times 2, 10x ln x. There are two ways to do that. One is to keep the 10 out as a common factor. One is to make it part of x, so it becomes 10x. I'll quickly show you both ways. Because 10 is just the basic number, it's not really too bad. This is your function 10x. Its derivative is 10 times ln x. We are using the product rule. So 10 times ln x. And now here's your g. Ln x is 1 over x times 10x. Needless to say, this is just 10. And if you factor out the 10, that's your final answer. If you kept this as 10 times x ln x, and as I mentioned, 10 is not a huge number. It's not that big of a deal. But if it's involved, you really want to go this route and keep it out. So now you're looking at x gives you 1 times ln x. You're looking at ln x gives you 1 over x times x. And I hope you see that it's 10 times ln x plus 1. The same thing. Now, really doesn't make that much of a difference in this example. All right, let's go to the next one. So let me clean it up. We want to differentiate this, and that means we are going to use the quotient rule. The top is f, the bottom is g. The derivative of the top is 1 over x times x. So that's f prime g minus g prime f. The derivative of the bottom is 1 times ln x. And then over the bottom squared x squared. Again, you can keep on writing ddx of this, ddx of that. It becomes very difficult to follow sometimes. This product is obviously 1, and this is ln x. So 1 minus ln x. And that's the final answer. All right. Can we differentiate the way it is? Yes. We have to write the reciprocal of this. That means 1 over this. And then differentiate this using the product rule as well as the chain rule. It is easier to decompose this first. Can you tell me what is the decomposition of this log? Anyone? You can do this in one shot, but let me take a couple of steps. This is ln of 3x plus ln of x plus 4 to the power of 5. So ln of 3x is ln 3 plus ln x, and this one 5 sits in front, becomes a coefficient. So that's algebra, basic algebra. If you do this, it makes it very easy to differentiate one by one. This one is a number. Ln of 3 or ln of 2 or ln of 5 or ln of any number is a number. The derivative is 0. Ln x, 1 over x. plus 5. Now ln of x plus 4. Flip this over. The reciprocal of this is 1 over x plus 4. By the chain rule, the derivative of the parentheses. The derivative of the parentheses happen to be 1, but you should write it in case it's not. And this is the end of calculus. Everything else will be algebra. So this is 1 over x, this is 5 over x plus 4. Product of x and x plus 4 is the LCD. 1 times x plus 4 plus 5 times x. That's the numerator. We can combine these two into 6x, and we are done. So 6x plus 4 divided by x times x plus 4. Decomposing the log makes it easier to deal with this differentiation. We want to differentiate y equals e to the power of 2x times ln x. First and foremost, we put the raised dot in between, which means we are going to use the product rule, calling this f, calling this g. So e to the power of 2x, the derivative is itself, e to the power of 2x, times 2 by the chain rule, times ln x by the product rule. So this is f prime, this is g, plus g prime f. What is the derivative of ln x? 1 over x times f, which is e to the power of 2x. Notice this is f prime g, this is g prime f. And we can factor the e to the power of 2x out as a common factor. So if we take this out, this gives us 2 ln x, this gives us plus 1 over x, and that's the final answer. Y equals log base 3 of square root of x. So we want to differentiate this, and we have learned how to differentiate when the base is e. But what happens when the base is anything other than e? We use the change of base formula. We remember the change of base formula. Log x base b is ln x over ln b. You can think of this just to make sure we don't make a mistake. You can think of this as 1 over ln b times ln x. 1 over ln b is a number. It's like 5, like 2. Of course, it's not that, but it is a number. So when I want to differentiate this, I say the same thing times the derivative of ln x, which is 1 over x. So y prime is 1 over ln b times the derivative of ln x is 1 over x, and we write it in this fashion, 1 over x ln b. What if we have log, some base, and a function of x, and that means f of x or g of x or h of x? That means we have to tag along the chain rule. So how do we differentiate this? Because it's log, reciprocal of the argument, 1 over f of x. If the base is e, so be it. If not, 1 over ln b. By the chain rule, we need the derivative of that, f prime. Put them all together. This is the answer. So going back to question, log base 3 of square root of x. We are going to write this as x to the power of 1/2 first, and 1/2 becomes a coefficient because we are using the power rule. So this is algebra. Now I want to differentiate this. So y prime is, we keep the 1/2. This is log, so we're going to flip this over. 1 over whatever this is, 1 over x. Is the base e? No. So 1 over ln of whatever this number is. This is by the change of base formula. And since x is the independent variable itself, it's not a function of x, it's just we don't need to multiply by its derivative, which is 1. So we rewrite this as 1 over 2x ln 3 as the final answer. So a quick recap, use square root of x and we change it to x to the power of 1/2. The power rule puts the 1/2 in front. So to differentiate, 1/2 remains because it's log 1 over the argument of log, because the base is not e, 1 over natural log of the base. And since it's x, we are done. If it wasn't, we would use the chain rule and differentiate that. Now, the very first thing we want to simplify this, we can. This is the simplified version. There is nothing else you can do algebraically. Now you're going to go do the calculus. So we're going to do f prime of x. It's a log. Flip this over. 1 over x squared plus 1. Chain rule. What is the derivative of that? 2x. Is the base e? No. 1 over ln phi. You can put them in any order. You can put this first or this one first. It doesn't make any difference. So you flip this over. You need the derivative of that by the chain rule. And you need 1 over ln of 5 because the base is anything other than e. By the way, in case if it was e, 1 over ln e, you should know it's 1. So it makes no difference. Now we put them together. 2x is in the numerator. And the product of x squared plus 1 and ln 5 is in the denominator. Bear in mind that ln 5 is not missing. ln 5 is a number, but we keep it as ln 5 because it's an exact answer. All right. Y equals ln of sine x. Well, what is the derivative of ln of g of x? First and foremost, whatever this is, flip this over. 1 over sine x, everybody, times the derivative of that, g prime of x. What is the derivative of sine? Cosine x. And you should know cosine x over sine x is cotangent x. Cosine x over sine x is cotangent x. We want to differentiate y equals 1/2 ln of 1 plus x over 1 minus x. So first thing first, we use logarithmic properties to decompose the log. 1/2 remains. This is ln of the top, 1 plus x, minus ln of the bottom, ln of 1 minus x. So this expression, see 1/2 doesn't change. And this expression is cut into two pieces using the quotient rule. Now we are going to differentiate. So y prime is 1/2 is going to remain. It's not going to go anywhere. So y prime is 1/2. So the reason I'm using brackets because 1/2 is being multiplied by everything. So 1/2 times whatever we are going to do. So we are going to differentiate this. What is the derivative of natural log? Flip this over, 1 over 1 plus x. And then by the chain rule times g prime of x. What is the derivative of 1 plus x? Is positive 1. And again, it makes no difference because it's positive 1 whether you write it or not. However, pay attention to what happens here. Minus ln of 1 minus x. So minus, flip this over. Now, g prime of x. What is the derivative of the parentheses? That is negative 1. And now it does make a difference. You must write times negative 1. And that is extremely important. So what happens next? We are done with calculus right here. Calculus is done. Now we are going to combine this. This is 1 over 1 plus x. This is plus 1 over 1 minus x. Again, 1 over 1 plus x. Negative and negative plus 1 over 1 minus x. First and foremost, the product of these two is the LCD. So 1 plus x times 1 minus x is the LCD. Now, 1, so maybe I quickly write at the top of it. You should recognize this is one over 1 plus x plus 1 over 1 minus x inside the brackets. Therefore, the product of these two, 1 plus x and 1 minus x, the LCD, 1 times 1 minus x plus 1 times 1 plus x. That goes to the numerator. So again, the product of these two pieces is the LCD. 1 times 1 minus x, negative and negative positive, 1 times 1 plus x. All we have to do is simplify the numerator. So let's do that. So this is 1 minus x plus 1 plus x. And I hope you see that this simplifies to 2 because x and negative x cancel each other. 1/2 cancels out the 2. So we simply have a 1 in the numerator. And the denominator is the product of 1 plus x and 1 minus x. I hope you know it's 1 minus x squared. This is the final answer. Now, what about something like this? ln of ln of 5x. I hope you remember when we were differentiating and we were getting started with the chain rule, I said the way you approach the sine and cosine is that when you read sine or cosine, you pause and it helps with the differentiation. We're going to do the same thing here because ln has an argument. Sine and cosine, they have arguments. So ln, and you stop. I would just read this as ln, which means if it's ln and nothing else, I have to flip this over according to differentiation of natural law, 1 over x, or in this case, 1 over g of x. This whole thing is a g of x. You can even call it g if you want. This is g. So 1 over g, 1 over ln 5x. So that's the first step. Now I want g prime. Remember, it's ln 5x. What is the derivative of ln 5x? Well, you flip this one over, 1 over 5x. You flip this one over, 1 over 5x. And then the derivative of 5x by the chain rule, 5. And you put them together. Now, before we put them together, you notice this 5 cancel out this 5. So the numerator is 1. And the denominator is ln 5x times x. So we put the x in front. 1 over x ln 5x.